So welcome back to the third video of this playlist. Now I will cover main content like international system of units in this video. So what is international system of units? In 1960 an international committee described a set of definitions and standards to describe the physical quantities. A set of definitions and standard to describe these base quantities and derived quantities is called system international. We have already learned about that. To measure a quantity we need the choice of standard and second the procedure. So first step is to the choice of standard. The standard is the international system of units. Due to simplicity and convenience with which the units in this system are amenable to arithmetical manipulation, it is in universal used by world scientific community and by most nations. The system international is built up from three kinds of units: base units, supplementary units and derived units. We will see one by one these base, supplementary and derived units. So first one is the base units. The units which are used to define or measure the base quantities are called base units. For example, these base units, these are 7 base units for physical quantities like length, mass, time, temperature, electric current, luminous intensity. Intensity and the amount of substance with a special reference to the number of particles. The names and of these base units are described in this table and we will see. First one is the length. Length is measured in SI units meter and symbol is written as small m. Next one is the mass. Mass is measured in terms of kilogram and it is represented by kg. Next one is the time. Time is also a base unit. Its SI unit is second and is written as S. Electric current, ampere with capital A, thermodynamic temperature, Kelvin with capital K, intensity of light, candela, CD, amount of substance in terms of mole and is written as mol mole. Next one is the supplementary units. The General Conference on Weights and Measures has not yet classified certain units of the SI under base and derived units. Normally the units which are neither in base or nor in derived, they are called as supplementary units. They are still not being defined either in base units or in derived units. Mainly these quantities are not either base quantities or nor these are derived quantities. These are supplementary quantities or they are measured in terms of supplementary units. These are also SI units. These consist of these are purely geometric quantities. These are plane angle and solid angle. Now we will see plane angle is measured in terms of radian and its symbol is RAD. Solid angle is measured in terms of steradian and its symbol is SR. Next one is the radian. First we will see radian, then we see steradian. Radian is the plane angle between two radii of a circle which cut off the circumference of an arc equal in length to the radius as shown in figure. So a figure is shown with a circle. It says that the angle subtended at the center of the circle when two radii of the same length, first radii, second radii, this is the circumference of the circle, when two radii cut off the circumference and the angle subtended at this center of this inclination of two radii is called as radian simply. Next one is the steradian. Steradian is the solid angle, three-dimensional angle subtended at the center of the sphere by the area of its surface equal to the square of the radius of the sphere. So this is a sphere and it is a three-dimensional angle subtended at the center of the sphere. This is a sphere. When a sphere is shown in this figure, this is the subtended angle at the center of the sphere by an area of its surface equal to the square of the radius of the sphere. So the angle subtended by this sphere is equal to the square of the radius of the sphere. So the angle between in this spherical surface in the center of circle, which will be measured in terms of steradian. So next one are the drive units. Drive units are the SI units for measuring all other physical quantities, like the quantities which are used to measure the drive quantities are called as drive units. These are units measure for all the physical quantities from base and supplementary units. First one is the force. Force is measured in terms of Newton. Its symbol is N. In terms of base units, its units are kilogram, meter square, meter per second square. Next one is the work. So next one is the force. Force is written as F is equal to ma, where m is equal to kilogram, unit of mass, and a is equal to meter per second square. When you will write both the units of mass and kg, like m and a, you will get the unit of force Newton. This is a drive unit in terms of base quantity. And similarly, our unit of work is joule. Joule work has defined as F dot D. F unit force is Newton. Newton we know that kilogram meter per second square. When you multiply this with meter, this will give you kilogram meter square per second square. Similarly, we can derive other units like power. Unit of power is watt, joule second. Unit, we will put the unit of joule from above written joule units, and similarly we will get the unit of power. Unit of pressure is Newton per meter square. P is equal to F over A, and we know the Newton already is equal to kilogram meter per second square. When we will put over here and multiply with this per meter square, we will get kilogram per meter per second square. Unit of electric charge is coulomb, represented as C, and the unit is ampere second. So that's all from this video. We will continue this chapter from next video.